So, last class we discussed about this approval from MOEF. To get the approval we have to prepare a detailed project report. The detailed project report shall contain all these parameters what I am going to tell today. The first parameter is the ship size, that is the design ship size. There will be various ships that will be coming to the berthing facility. What are the different types of ships? Panamax, capesize. Any other type of classification? Containers and tankers. So, you have to decide, suppose you are using a general cargo, container and bulk cargo and tanker. For each one of them you have to give the size of the ship, whether it is a Panamax or I told one of the classes crude oil will be coming in one size and the refined petroleum product in another size. What is the size crude oil will be transported? What is it? Crude carrier, what is the size? Is it Panamax size or what size it is? Cape size or more than cape size? VLCCs, that is a cargo that will be transported for crude, whereas for refined petroleum products it is Panamax or less than Panamax. So, depending on the cargo what you are, either it is import or export, based on that the size will vary. The expected cargo details means what is the volume of cargo, how much a berth will handle a traffic, how many million tons it will handle. Suppose you are building one berth in a port facility, how much cargo it will handle, how many million tons, how many vessels it is approximately it will receive in a year. 5 million tons, how many vessels it will receive? How many days are there in a year? How many days are required for a vessel to be berthed and evacuated? 2 to 3 days. Then how many vessels it is approximately? 100 days, about 100 days. The 365 days the port may not operate because of some cyclones and other things. So, 100 vessels, if it is Panamax size it will be 6 million tons, that is what the cargo that will be evacuated. The expected cargo details is to study how many berths are required. Suppose you want to handle 12 million tons of bulk cargo. In Indian scenario we generally give 3 berths because we will be handling only 60,000 DWT vessel. If you are using a cape size or bigger size vessel, 2 berths will be sufficient. So, that is what is given here. What is the berth requirement? What is the cargo handling rate? At the end of the course you should know how much cargo will be handled in a day or in an hour. It has been told to you earlier also. Who are all mechanical engineering students? Raise your hands. Mechanical engineering, how much cargo they will handle? Guess some value, don't keep quiet. 2000 tons per hour, that means how many tons per day? Into 24 is not correct, into 20. Generally we take 20 hours only, 40,000 ton per day, that is the handling rate. If you put more conveyors and more cranes, then you can increase the rate. That is what is coming here about the cargo handling equipment. The operation time, berth occupancy in Indian scenario it is more than 70-75%. In Singapore it is around 50-55%. What is desirable is 50-55%. The berth has to wait for the ship should not wait for the berth. There is so much congestion in Indian ports, it is required that we have to reduce the berth occupancy, you should not increase the berth occupancy. The berth requirement for master plan also you should give. Master plan means whenever you design a port, you should not design based on today's scenario, you have to design based on 20 years, 25 years or 100 years. So for a master plan you should always position some berths which are required. Another important parameter is the storage requirement of different cargo, that is how much storage is required. Generally they say for 1 million ton about 1.5 acres are required as a storage requirement, but sometimes it may be higher also depending on the type of cargo. Fertilizer, wheat and other things we may need much higher area. Kandla Port Trust gives about 8 hectares per million tons. Then we should know about these buildings requirements. Then receipt and evacuation of cargo, you have to know about the port access road, railway system, water and power requirement. Generally we have to provide this desalinated water as well as water for the ships, power requirements also. Then we have to discuss about the master plan of the port, and there are two parts in master plan. One is inside the port harbor basin, another is on the shore landside facilities. Then we classify the works into two categories, civil works and mechanical works. The civil works are generally breakwaters, berths, dredging, site grading, open and covered storage shed, port buildings, railway and roads. These are the major components of engineering civil works. And engineering of mechanical handling system, ship loading and unloading system, conveyors, stackers and reclaimers, port handling system, break bulk cargo handling system. These are the various handling systems that has to be done. Then we also need to have engineering electrical works, electrical power source requirement, substations, illuminations and cables. So we have civil, mechanical and electrical works in a port. Generally this civil works and mechanical works are almost equal cost. If you see major port facilities, the civil works and mechanical works, the cost is almost equal. Electrical works and utilities, that will be around 25% of the total cost of the project. Utilities include buildings, roads, railways and railway exchange yard. I do not know, there is a mistake here, water drainage and sewerage, bunkering and security systems, port crafts like tugs, pilot and mooring launches. Then we have navigation, fairway buoy, channel marker buoys, beacons, transit lights, VTMS. Now what is VTMS? Any idea? Vessel traffic management system. This most just like air traffic controller, there will be a vessel traffic controller will be there. It is not in place in Indian ports, but this is very much required. So every day if you are getting around 10 vessels, you have to manage how to bring these vessels and take these vessels out. Then fire and pollution control is also important. Fire control, you have to provide adequate systems for water to be pumped in. Pollution control, if it is a dusty cargo, you have to sprinkle water, you have to put some barriers. These are all the pollution control system. Then we have port administration and management for terminal operations and organization structures. So finally the DPR should consist of two parts, one is the capital cost, another is the operation and maintenance cost. I told you earlier 1 million tons of cargo if you want to handle, if you want to create a facility, it will cost between 60 crores to 100 crores, that is the bandwidth of cost that will give you a rate of return which is sufficient for bankers to finance the project. Generally most of the port infrastructure projects are financed by banks, 25% only is put by the developer, balance 75% the banks are financing, unless there is internal rate of return which is about 12% on the capital cost estimate. It is very difficult to get the sanction from the banks. Then you have to also write about the operation and maintenance cost. Some of the operation costs are not some of the capital costs are included by leasing equipments. I told you about this navigation, tugs, pilots, mooring systems, sometimes the cranes, sometimes some small feeder cranes or the forklift trucks, all of them are leased, then it will go into the operation and maintenance cost, it will not be in the capital cost estimate. Then you have to also give what is the project implementation and the phasing of investment. That means when you want to implement the project, how much time you think it will be required for developing a greenfield port? What will be the duration? How much? Greenfield for 2 to 3 years, that is a usual period. Then you have to give what is the phasing of investment also. So this financial and economic analysis we have to give, internal rate of return and things like that. Once you complete all these facilities, then you have to get the clearance from State Coastal Zone Management Authority, then you have to give the details of construction activities to be taken in CRZ area, then you have to get the consent to establish, then you can start carrying out the project. These are the various steps involved in getting the clearance. So there are certain basic designs that are required that we will be seeing in today's class. One is a navigation channel design. One part of the navigation design is it can be either a single lane traffic, that is called as a one way traffic, another is called as a two way traffic. You should know what traffic you are carrying out. So this is a natural bed level, this is the lowest water level, so the depth available is not sufficient, so you create a dredged pit here. We should find out what should be the width of this lane for one way traffic, and also you have to find out what is the depth required. The width required consists of two parts, one is the maneuvering lane, another is the bank clearance. So this should not go very close to the bank, there will be some section effect from the banks, so you have to provide a bank clearance, and then you have to provide a maneuvering lane, because when you are moving the ship it will not go in a straight line, it will go this way that way, for that you have to have a maneuvering lane. In the case of two way traffic, you have a bank clearance, you have a maneuvering lane, and in addition to that you have a ship clearance, because between the two ships maneuvering lanes there should be a ship clearance. This is basically what is required in a navigation channel design. So for multi channel you have to separate maneuvering lanes by a ship clearance lane. So this degree of interaction, how much you have to provide, it depends on the channel shape, it can be straight or it may be curved, what is the depth of the channel, what is the speed of the channel, what is the current, swell and wind. What is the vessel speed normally inside a harbor basin when you want to bring in? How much? Normally it is about 2 to 3 knots, it's about 1 meter per second. They sometimes switch off the engine and the tugboats will bring it in. Currents are very serious considerations if the current is perpendicular to the direction of the ship. What is the difference between swell and sea? Ocean engineering students, what is swell and what is sea? Both are waves, what is the difference? Not ripples. Due to wind, if the waves are created at the same location, it is called as a sea. Suppose it is created near Bengal and comes to Chennai, it is called as swell. So the waves are created elsewhere, then it comes here. So swell is generally a long period wave, it is more critical than a sea. Sea is generally about 3 to 6 seconds, what you call as a ripple, sometimes it can be more also, generally it is between 3 to 6 seconds, whereas swell is more than 12 seconds. So the ship clearance lane is about 30 meter or beam of the larger vessel, whichever is greater, upper limit is half the combined beam widths of the vessels. Both of these are likely to be excessive at low speeds. Suppose the speed is less, whatever you are providing 30 meter or one width of the ship or half of the bigger ship plus half of the smaller ship width, it is excessive if it is a low speed. Bank clearance is when there is a suction due to asymmetrical flow of water around the vessel, you have to provide the bank clearance. Generally we provide a trapezoidal section, this will produce less section than a steep sided canal section. So if you see the if this slope is steeper, the section effect will be more, if it is trapezoidal it will be less. Underkill clearance sometimes called as UKC, this depends on the bank section increases as underkill clearance decreases. So this bank section also is a part of underkill clearance. How much we provide underkill clearance generally? It's not in meters, it is a percentage of something. What is it? 10% of the draft if it is inside a harbour basin, if it is outside a harbour basin it is 20% of the draft. So this gives the total channel width requirement widths of all the three lanes. Then Permanent International Association of Navigation Congress, this recommends the total width of the channel. For single lane it is between 5 to 7 times the vessel beam depending on the sea and wind condition, that is between 5 times the beam of the vessel to 7 times the beam of the vessel. The double channel is about 9 times the width of the largest vessel. So this is some approximation. Normally the length of the ship is equal to 7 times the beam of the ship. So the width of the channel also you can assume approximately as equal to the length of the ship. Why should we worry too much about this navigation channel? What are the implications? You are designing something, I am teaching you how to design. If you do not design it properly, what will be the consequences? You have to answer when you are designing something. Suppose you have to provide 7 times the beam of the vessel, suppose you provide only 3 times the beam of the vessel, what will happen? What will happen if the width is less? It is not getting grounded, it may go and hit the sides, then it will get grounded. Possibility is the ship will not come inside. Instead of 7 times the beam of the vessel, suppose you provide 14 times the beam of the vessel, what are the implications? What is the impact of dredging? One is cost, another is environment. So this is so you have to provide a design which will be. There is one more thing which I do not expect you to answer, that is there are two aspects in the port design, one is called as a tranquility, another is called as a ship maneuvering. So navigation channel it is wider, it has a problem on tranquility. So in a DPR we need these two studies, tranquility and ship maneuvering. So these two aspects are to be studied carefully. Tranquility means what will be the waves inside the harbour basin. So if you provide more width, the waves will pass through the width of the channel, and more depth also will transform more waves inside. So that also has an impact. So what are all the design approach for this channel design? First you have to select the design vessel. So a design vessel is based on the overall economic interest of the port in Cochin. So when we want to select the design vessel, you should see for a type of cargo what is the majority of the maximum share of the cargo, in what size of the vessel it is being transported. So you have to design for that vessel. So this basic vessel characteristics you have to design, whether it is a container vessel or oil tanker or things like that. Then you have to find out the environments like water depth, tide, current, wave and wind. Also you have to establish the vessel speed and tug assistance. So if you provide a better tug assistance, then you need to provide lesser width, maneuvering becomes more easy. You have to estimate the required channel depth. So to estimate the channel depth you have to find out the under keel clearance. What is told is approximate, but you have to calculate. It depends on various parameters like trim, squat, type of seabed. If it is a rock you have to provide more under keel clearance, if it is a clay soil less. You have to estimate the channel width. This can be done by a maneuvering analysis. You have to put the channel over the existing site bathymetry, then you have to do a simulation with the channel dimensions. You can have a real time simulation. This real time simulation is just like aircraft when they get some training. Similarly the ship pilot will do a simulation. It is there in Indian Maritime University, the real time simulator. One more private engineering college also has this simulator. There they will mark the layout of the channel and bring in similar different types of vessels and put different environmental conditions and see whether they are able to bring the vessel inside. Then you have to find out the requirement of navigation aids. There will be some marker buoys which will show where the channel is, that is the navigation aid. The vessel traffic management system VTMS, that also will give lot of aids. Navigation aids is not only the buoys on the entrance channel, there will be a navigation tower which is the tallest building in a port. From there, just like air traffic controller, no, where he sits and sees all the vessels coming, from this tower also they will be giving. There will be some lighthouse kind of thing in the navigation tower, the ship can see, and there will be 2 towers, so you can align the ship with reference to the, if it is one tower you cannot align, so there will be 2 towers. So you have to calculate the dredging cost and economic and environmental feasibility. This we have discussed just now. So we have to develop the natural channels in waterways that are naturally deep or at least deeper than alternate harbor locations. This is how you have to decide. That means suppose nowadays we have to bring the vessel about 12 meter draft and 14 meter depth is required. Normally what we say is about 10 meter water depth, what distance it is available from the shore, because 4 meter you can dredge. So 10 meter depth is available at a distance of about 600 to 800 meters in Gopalpur port. So you can select at that location. Whereas Paradip, which was developed long back, the 10 meter contour was available more than 1.5 kilometers. So that was not a correct location. Location depends on where the deeper contours are available closer to the shoreline. So for rivers also they are giving some of the details which rivers are better. So this is called as a windrows diagram for offshore Long Island, New York. What is given here is the wind speed in knots. This symbol is 0 to 6, 7 to 16, 17 to 27 and 28 to 40 knots. So these are the different directions through which the winds are coming. So you have the direction which is coming is maybe south to southwest, you have maximum direction of wind that is coming in, that is this is a percentage, how much percentage it is coming, each circle represents some percentage, this is 10%, this is 20%. So for example here it is about 0 to 5% is 0 to 6 seconds, 5 to 10%, 5 to 15%, it is about 10% of the time, it is 7 to 16 seconds, and this is maybe about 3%, 17 to 27 knots. Is it clear? This shows the direction, that is the wind is coming from south, it is coming. There are 3 types of wind speeds, one is 0 to 6, another is 7 to 16, third one is 17 to 27. 5% of the time the winds are coming from the southern direction with a speed of 0 to 6 seconds. About 10% of the time it is coming from 7 to 16 seconds, 16 knots, and about 2.5%, we will say it is approximately 50%, 2.5% of the time it is between 17 to 27 knots. So like that you can find, and calm is very calm, maybe very close to 0, is about 3.2%. This is the wind speed windrows diagram. Wind also has significant impact, but the waves can have a significant bearing on navigation channel depths and widths. So this is mainly for the outer portion of the entrance channel, where vessels must transit without protection from ocean wave attack. Current also have a considerable impact. The currents can be of tidal origin, may be the result of river flow or both. River flow means it is from the river to the sea, tidal means it can be into the river or out of the river. Suppose you have the shoreline here and you have 2 breakwaters. Generally the breakwaters are stopped at -10 contour, then we have a navigation channel. Depending on the direction of wind and wave, we orient the ship. Typically the width of the entrance channel is given is about 400 meters, this is about 200 meters. The length of the channel from the center line to this is normally about 7 times the length of the vessel, typically around 1500 or 1600 meters. This is a normal behavior. The problem for the ship comes when 50% of the ship, major portion of the ship so this is the center line of the ship, some portion of the ship is inside, some portion of the ship is outside. This is very critical, because this portion of the ship is subject to less wave and current, whereas this portion of the ship is subjected to more wave and current. Suppose there is a ship here, the maneuvering is not that difficult, even though the waves are higher for the full length of the ship, it is not very critical. Another thing is if there is some slight tilt, it will go and hit the breakwater, some structure. So this portion, that is what is written there, where vessels must transit without protection from ocean wave attack. So this only create not a problem. So we have discussed about this return period and significant wave height. This shows the average estimate, that is this is your average estimate for the wave height. Suppose it is a 10-year return period, it is about 1.2 meters. If it is 100-year return period, it is about 3.8 meters. So this is 10, I think this is 20, 30, 40, 50, 60, 70, I think something is, maybe it is a log scale. So based on that you can find out, maybe it is ton square and ton power 1. So in between it will be distributed. So we have to estimate, so if we go for 1000 years, it goes to 5.2 meters. So depending on the, this for one particular port, what will be the value, and this is an average estimate. This can be higher or lower also. This is the 99% confidence level. Within 99% confidence level, you have to choose between these 2 points. So this only average means it can exceed also. The 99% confidence level band is this. So, this channel depth, so what we have discussed is so far what is the wave, what is the wind, what is the current to be considered, then you have to go for the design. One is a loaded vessel draft. So, if you see the ship, there will be some trim will be there, it may be inclined like this because of how you are loading the ship. Then squat, there will be wave induced motions, there will be 6 motions due to wave, heave, surge, sway, pitch, roll and yaw. Then you have to give the safety clearance. The safety clearance depends on the soil type. If it is rock, you have to provide more safety clearance. If it is clay, you have to give less safety clearance. Then you have to talk about the dredging tolerance. When you want to dredge exactly minus 14, you may not be able to do. So, you have to give some tolerance for dredging, that is normally given as about 0.3 meters. Then this is called as the advanced maintenance dredging. Sometimes what they do is, if you want minus 14 including dredging tolerance, it comes minus 14.3, and every year you assume about 10 centimeter siltation takes place. Then once in 5 years only you want to do the maintenance dredging, then you go in for 14.8 meters. So, 12 meter is the draft. So, we have under keel clearance of 2 meter, this you calculate 14 meter. Then you have the over dredge allowance. .3 meters, 14.3. Then you have advanced maintenance dredging. So, this acts like a silt trap. If you assume it will take 0.1 meter per year, multiply by 5 year, and it gives 0.5 meter. Then you do capital dredging itself as 14.8 meter. Sometimes it can be 0.2 meter, can be 0.3 also. So, you dredge more initially, which will be less expensive, and maintenance can be done once in 5 years. Some ports do not carry out this advanced maintenance dredging, but we normally recommend this advanced maintenance dredging. We are designing a floating dock in Port Blair. The floating dock is kept by the side of the berth. The floating dock is maintained once in 5 years. So, below the floating dock for 5 years we do the advanced maintenance dredging, where the floating dock will be in the same position for 5 years. So, the vessel draft can be fully loaded or lightly loaded conditions. So, you would normally take the fully loaded. Sometimes we have to limit drafts to assure safe navigation. That means we may not load the vessel for the full load to aid navigation. For example, if the berth is the port is designed much earlier and it cannot take higher draft, but you cannot go and change the vessel, because there is a particular type of vessel which is most commonly used for a particular type of cargo. This point is clear, you cannot change the size of the vessel because it will not be available. Use the same vessel, but use it for lesser draft. That means instead of 100% of loading the vessel, they may load 70% only, then bring the vessel inside. In Goa they do something else, there they are loading iron ores, they bring big size vessels which will go to mostly Japan and China, where the vessels can have a draft of 17 meters, draft can be 17 meters, not the depth, whereas Goa it can be only 12 meters. What they do is they load for 12 meter drafts in Goa port, take the vessel outside. Then in the open sea they do a transshipment terminal, that means you will have a transhipper. Transhipper is just like a ship with some crane facilities. then you bring the vessel on one side, bring small barges which are coming from rivers in Goa. So, there will be cranes here which will take the cargo from here and load it here. So, this may be a cape size vessel which the Goa port will not be able to handle. So, they will put a transhipper here and go to 20-meter contour or 30-meter contour. This is being practiced now. So, they will have only 70% draft inside the harbor basin, then bring it here and top it up and take it to Japan, because you cannot go with the empty 70% loaded draft all the way to Goa. The reverse also is possible. In Tuticorin port they want to do like this, they will bring a bigger vessel, they will lighter the vessel, then bring it inside the harbor basin. So, today we will discuss about the squat. Squat is the increase in the draft. So, the position of the vessel keel related to the channel bottom will lower with increase in vessel speed. That is, this is the bottom of the vessel, this bottom of the vessel will go down, that means the clearance will become less in the restricted waterway. Normally in deep water you will have this kind of buoyancy distribution. This is a support which is given by the vessel, that is the pressure distribution, it is a pressure distribution, whereas in a restricted waterway there is some increase in flow velocity below the ship, because of that the pressure distribution will increase. When the velocity decreases, pressure will increase. So, in deep water case the ship floats by buoyancy, shallow water, water is compressed between the seabed and the ship's body and runs out faster. So, there is the effect of bottom here. So, in shallow water this water between the ship bottom and the seabed is compressed and flows faster. According to the Bernoulli's principle, the pressure decreases when the ship speed increases. So, when the pressure is decreasing, then the ship will go down, a low ebb is formed attracting the ship downwards. Before and after this hollow the waves are also higher, this is what is called as a squat. So, when increased water velocity flowing past a moving ship will produce a localized lowering of the water surface. Squat is a function of vessel speed, underkill clearance, channel width and depth and vessel dimensions, and this squat varies with the square of the forward speed. So, the speed is more, squat means how much clearance got reduced, increase with the square of the forward speed, squat increase as underkill clearance is reduced. Squat is larger for width restricted channels than in open areas. If the width is restricted, the squat will be larger. So, you have to take care of this squat, then finalize the design. Okay.